Hi everyone. Yeah, it's really a pleasure to be here, and thank you for listening to me. So thanks for warm introduction of me. So yeah, I'm a senior data scientist in Gelato. Previously, I worked in TikTok, in Jump City, but all these years I've been into the experimentation industry, and it was my main focus. So this QR code, you can click on it. I have some blog with some sometimes interesting, cool stuff on A/B testing and data science in general. And also, I've incorporated a tiny experiment in this presentation as well. So one version, the images here, most of images are AI generated. And then the second version is all images created by myself. And the second one I show to my colleagues. And then eventually I'm going to measure, I would say, the positive feedback rate. And we'll see who's going to win, my creativity or AI. So I think the latter one. So what we're going to cover in this conversation. So first of all, A/B testing in all its glory. So what it is, why we need to do this, when. The second one, it's about experimentation cycle. So what are the essential steps, what we should take into account when we are trying to implement some of our ideas. And the last one, it's about, in my opinion, the heart of every A/B testing system. It's experimentation design plus splitting system. So just briefly about what Gelato is. So Gelato is a global software company, and we focus on providing the platform to connect businesses and individuals with production partners for fulfillment and for just production. But in a nutshell, if you want locally produced mug featuring you or your dog, or you're an influencer and you want to start selling some merchandise, this is the place where you should start. About experimentation culture, I would say we're still in our infancy, but we've made quite a tremendous leap in it. And what I'm going to show you is a part of what we've already built inside. So let's start with definition. So what is A/B testing? So let's assume you have some product, business, some audience, and you want to test your new feature. So you just have to split your audience into A group, B group. So A group, we call it control group. And for these guys, we show the old version of it. And for B group, we call it treatment group. And we show the brand new feature. Then we apply some statistical magic and eventually decide if our feature is beneficial for our business or not. So, but why we do it? I mean, why we just can't roll out this feature to the whole audience and that's it, and then just to keep an eye on metrics and to decide. So turns out there are two good reasons. So this is the first one. It's about correlation versus causation. So I'm sure all of you hear the expression, the saying that causation doesn't imply was opposite. So correlation doesn't imply causation, and this picture depicts it. So it's like number of people who drowned in a swimming pool correlates with power generated by US nuclear power plants. So, but does it mean that one causes another? Maybe yes, maybe no, but we don't know because maybe there are some hidden factors that influence all of this. So the A/B testing, I would say, is a golden standard when we want to prove that something has become better or worse, especially because of our change. And the second reason, so let's assume we have some product, we've implemented a new feature, and it's 10% drop in our average revenue per user. So when we don't run A/B tests, so we're going to lose 10%, and that's it, because everybody everybody has already seen this new feature. But with the experimentation, we're just gonna lose 0.5% because we're gonna show this new feature just to a part of our traffic. I mean, 10%, it depends on many factors, and we're gonna talk about it, split 50-50, and the eventual result is 0.5. But the final outcome is the same. I mean, we realize that one is worse than another, but we just lose a lot less. So, what most of data folks hear and think when they hear A/B testing. So, it's all about statistical significance, t-test, bootstraps, and all of it. But in reality, there is a lot more that we can't see. So it's about decision making, splitting, design, and we're going to cover it later. I mean, later right now. So about experimentation cycle. So it all starts with an idea. It can be, for this step, it can be a bit vague even. So just, I want to adjust our onboarding experience, adding some new steps, and we want to focus on some exact metrics. Then it comes design phase, where we highlight the metrics that we're going to keep an eye on, the metrics that we aim to change, the duration of the test, what exact customers we focus on, and other things. Then I call it admin panel, but it's just the control center where we manage and launch all our experiments. Then it comes to splitting. So it's quite obvious for now, and we'll dive into this deeply later. So the main purpose of it is just to split the users into A and B group and into different experiments. Then treatment. Treatment means we want to ensure that the right users get the right experience and how it's going to be implemented on the app or website, whenever it can be. Then logs. So logs, it can sound boring and even mundane, but it's really pivotal. Trust me. So if you come across the question whether should I log it, you should. So metrics. Metrics, I mean, we've defined some metrics on the design phase, but the tricky part here is that every, I would say, team and even every person in the team can have their own interpretation of the metric, and it's really essential to build the metrics hierarchy, to automate the pipeline, to calculate it, just to avoid two different results rerunning the same pipeline. Then I would say the most favorite and alluring part, so statistical tests. So it's where we decide, with statistical methods, is our feature really beneficial for us or not, and should we roll it out or not? And it boils down to decision making. So it can sound, just like simple, just look at p-value and that's it. But no, for example, if all of our metrics stay put, what are we going to do? So, or some metrics have increased and some just stay put, what are we going to do? Or there are some borderline cases, and it's where we should think about and implement some, I would say, decision trees. So I also mentioned that we're building in Gelato experimentation culture for the last 6 months, but what is it? So in my opinion, it's the combination of all these steps in order to create a cohesive picture. Then let's go to design. So we're going to cover design phase and splitting. So hypothesis. It's not already an idea. So in this stage, we transform from idea to hypothesis. What's the difference? Here we know for sure what we're going to test, what the features we're going to implement, on what customers we're going to focus. Then prime metric and quadrilateral metrics. So prime metric is a metric that we aim to change with our new feature. And quadrille metrics is just metrics that we should keep an eye on just to ensure that there is no negative most of the time or positive impact on other aspects of the products. And also here we shouldn't forget about minimum detectable effect is, in other words, it's like the magnitude of the change that we expect. So then randomization and analyzation unit. So randomization is what we're going to split. So for most of the cases, it's just users, but it can be products, devices, sessions, whatever. And analyzation, it's at what level we're going to calculate our metrics. So it can be country-based, it can be region-based, it can be user-based. The action moment is when we're going to implement our new features. It may be upon some event trigger or when the user just opens the sessions. Statistical significance, it's really, I would say, important to define the statistical methods that we're going to apply beforehand, so before the experiment started, because we are unbiased before, and after we're biased. So we're going to infinitely look for some other method that's going to prove our side, so we just need to do this before the actual launch. So the stopping moment, it's just when we understand that the experiment ends and evaluate the results. If we use a frequent test approach, it's just going to be the duration. If we use Bayesian approach, like multi-arm bandits from the previous talk, it can be many things. For example, expected loss or something like that. And the last but not least, so definition of success and failure. Most teams, I would say, and people overlook it, but it's really also essential. So success means that we roll out the feature, and failure that we're not. And it's not just about p-values or others, so it's about combinations of metrics. It's about whether we achieved some thresholds of lift, or maybe we haven't reached, so what should we do? But yeah, so we have well-designed A/B test, but how are we going to launch it? So we use right now AML configuration. So it's just a text configuration doc where we outline every part of our experiment. And why it's really convenient, because I'm, and most of us, data-related people, and for us it's easy just to create this kind of file and just push it and upload to the, I would say, control panel where the actual A/B experiment is going to be launched. Then about splitting system. So what's the goal of it? So let's assume the user comes to us and we want to decide whether he's going to be a part of the experiment or not, and whether he's going to be in a treatment or a control group. So the easy solution is just to hire a magician and ask him to reach out his back and pull out the random number and just pull out the random choice, and this guy is lucky, so he's going to be in our treatment group. But I believe it's not enough, so let's dive a bit deeper. So we have our user. For every user, we have some identifier, and even if our randomization unit is not users, for example, sessions, device, so we have our unique identifier. So what should we do? We should somehow randomly shuffle his ID, get some number, and then just map it out to whether or not he's going to be a part of experiment. So the common approach is use hash function. So I'm not going to dive into what the hash function is, but in layman's terms, it's, I would say, any function that can map some fixed size value, not fixed, any size value into fixed size value. And the benefit of hash function, it should be random. Yeah. So what are we going to do here? So we just get some hash function of our ID divided by 100. So 100, we're going to cover it later, why it's 100 and what can be the choice. And remainder of this operation is our special number. But what are we going to do next? Let's think about traffic. So we have our whole population, and we can split our whole population to n number of splits. We call them buckets. So here we just split it to 100, and yeah, so it's 100 that was in our random shuffling. And we can allocate some number of buckets to the experiments based on the sample size calculation. So in this case, we allocate 20 buckets to our experiment. If our special number is within this range, so he's going to be a part of our experiment. But how to decide whether he's going to show a new version or the old version? So quite easy. So we split one more time into 2 more buckets inside. So if it's less than 10, he's going to be a part of control group. If over 10 and less than 20, he's going to be part of treatment group. And yeah, so that's it. But no. So in reality, we run many experiments simultaneously. So how are we going to do it? So this is the whole our traffic. So we fill in our first experiment, then our second, third, fourth, and the last one. Yeah, so we're pretty booked in. Then let's assume a few days later, so the first experiment ends, and we free up new 20 buckets. So can we apply the same method to allocate the user to the experiment? No. Why? Because so the hash function of the user is going to be always the same number, and users tend to remember their past experiences and past experiments. So what should we do? We introduce a new ingredient called salt. In this case, experimentation salt. So it should be unique per experiment. So in reality, what it is, it's just ID of the experiment or title, so name. Yeah. So just visually, it looks like we split one more time, but just in another dimension. So not vertically, but horizontally. And yeah, so maybe that's it, but no. We have only 100% of traffic, and that's it. So it really throttles our capacity to run experiments. So how we can increase, this? So we introduce a functional layer salt. So it's, I would say, a distinct combination of your possible product dimensions. So what it is? So this is all dimensions you can have, and there are a lot more. So pages like main, search, cart, sign up, platform, clients, and type of clients. And so the combination of all of this is one functional layer. So for example, main plus web plus B2C plus all clients. And on all these different layers, we can independently run all our experiments. So we we have increased our capacity from just 100% of traffic by 100% of traffic multiplied by number of our functional layers. So the eventual formula looks like this. So we just get the hash function of ID, of experiment salt, of layer salt, divided by 100 and get the remainder. The common choice is to use 1,000 buckets. 100, it's just out of illustration purpose. So then, how are we gonna understand if our splitting system works? I mean, how are we going to measure the quality of it? So there are three main metrics. So the first one is sample ratio mismatch. The second one is false positive rate. And the last one is intersection between groups. So what is sample ratio mismatch? Let's assume we designed the experiment to split 50-50, like this. But in reality, it's like something like this, so 60-40. But is it okay or not? So I don't know, but chi-square test knows. So it based on observed values and expectation values. So expectation values, it's like 50% of our traffic, and observed, it's like number of what we get in every group. So if if p-value of this test is less than some threshold, then we can assume, 0.05 most of the time. So we can assume that something wrong with our splitting system. What can happen? So not only because our splitting system faults, like we've chosen the wrong hash function or something like that. Also because there are some development bugs. So right people get the wrong treatment or control group. And the last one is data capturing. So it's also very important here. So maybe we don't capture all the logs, or we just have some issues over there. Also important to notice that we should check sample ratio mismatch over different segments, like countries, platforms, and all of it. So let's go to false positive rate. So what is false positive? So false positive is the situation where we detect the difference, but in reality there is none. So false positive rate is just number of such cases over the total number, I would say, of, for example, experiments or simulations. So how are we going to detect this? So first of all, AA test. So we should not even run AA test online, but we should simulate it based on historical data. Then with existent splitting algorithm for sure. Then we calculate the statistical significance. We can use whatever we'd like. t-test, bootstrap, whatever. And then calculate false positive and eventually false positive rate. So it means in what number of cases the difference is statistically significant. So the benefit of using simulations is that we can get distribution of p-values. So if you have p-values of the difference in these simulations like this, so mostly uniform and hovering over the threshold of 0.5, it means that everything seems good. And if it's like this, so it's a bit skewed, and most of the cases are over, so it means that we are wrong at more than 5% of cases, and it's definitely not what we're looking for. And the last one, intersection between groups. So let's assume there should be men in control group and women in treatment group, but one man tried to blend in, and he is both in control and treatment group. And we can calculate it. For example, there is one intersection between groups over the number of unique users. In this case, it's going to be 1 over 9, I believe. Yeah. So why it can happen? Because of cookies, of also data logs, some bugs, because of many stuff. Yeah, so what we learned today. So the first one, it's about experimentation cycle. So it's not just about statistical tests. There is more to it. And we covered a bit of every stage. The second one, it's about experimentation design. So what are the essential parts of it? what should be included and what should be aware of. And the last one is system splitting. So system splitting internals. So what it is about, how we can implement it, and how we can make sure that our results are not biased. And I believe that's it. So if there are any questions, feel free to ask.
Thanks, Mark. Anybody like to ask some questions about how to do testing properly?
Thank you. Thank you for the talk. So I think as an experimental evangelist, how would you introduce experimental culture into new organizations that you work with?
It's a great question. Because I faced the same challenge in Gelato. So I would say I started with some prominent examples, where some other companies, big companies like Microsoft, etc., they showed the real benefit from using A/B tests. And also, I would encourage, stakeholders to use it, to try it, and to see if there are some benefits from it. And also, one phrase about successful ideas. Yeah, so in reality, so there is no pinpoint number for sure, but in reality, successful ideas over the total number of ideas, so this rate is really low. So why should we lose, money when we just can save it? Yeah, so I will start from it. Yeah. But yeah, it's a great question because I also reached out to some guys on LinkedIn just to ask, what your proposals to it. Yeah.
Anybody got any more questions? Can I just ask what people think? Why bother with a hash? Why not just use a uniform probability distribution and bin from that?
Yeah, so why not just use uniform distribution? Because you can't incorporate, this salt thing. And then if we introduce, this salt thing, so we can, I would say, increase our capacity, and we can make sure that our results are not biased. Also, even with this application, sometimes our buckets can be stale, and the solution to it, so for example, when our buckets free up, we're not just reusing it, but we, I would say, add them to the end, and it's going to be like an endless cycle. And this is going to help to keep your buckets and your experiment results really up to date and without any problems.
Okay.
Hey, hi.
Hi.
Thank you for the talk. So my question is, you talked about experimentation cycles and everything. In general, what I've seen, for example, offline experimentation and the online experimentation, the experience of it is usually very different. In the sense that sometimes we think, this thing should perform because it's doing so well offline, but it's sometimes when you take it online, it doesn't do that. What are your thoughts on that, and like why does it happen? And we have so many tests, you have so many health checks and all that happening. Even then, sometimes that just doesn't work out. You also mentioned how the ratio of the experiments succeeding is not that high anyway, which is the whole purpose of it anyway.
Yeah.
But like, why does it happen? What do you think?
Yeah. So by offline. So I don't have much experience with offline experiments, but the difference mostly it's first of all about cost. Yeah. So for example, you have different, I would say, shops, and you want to, for example, to change, the order of some items, but it's going to cost you quite a money, just to change it, to make sure that everything works properly. And online, it's a bit, more efficient. You just need to, click on the button, change it, and it's easier to make sure that everything is really stable. Also, so from my experience, so for offline experiments, we can use with more frequency, causal inference practices, and it really helps there. Yeah, so something like that. And also, the sample size. Yeah, if you run it online, most of the time you have, quite sufficient enough. And offline, it's, like maybe dozens, hundreds, etc. So that's why it's not better, because obviously causal inference methods have less power. But if you don't have other choices, yeah, you have to accept it.
Okay, any more questions for Mark? No? Okay, let's give him another round of applause.